In today's episode, we're going to give you a basic idea of how assembly language works. The native language of computers is binary, ones and zeros, but this is very difficult for humans to read and write. Most people learn assembly language to perform programming tasks that are not possible or easy with other languages. Programming in assembly language allows you to control every aspect of the computer's hardware. In this video, we're going to talk about the programming of the 8086 microprocessor. Today, most programmers write code in high-level languages such as Java and Python, etc. This is more usable by humans, but comes with the extra overhead of conversion back into ones and zeros. Assembly language is one step above binary, and by converting binary into mnemonic code, for example, move, jump, add, etc. These mnemonics are a term used to aid memory by linking terms through sound. In assembly language, they are abbreviations of commands such as JMP to jump to a position or MOV to move something from one place to another. It's a lot easier to remember than strings of ones and zeros.
Assembly language, as high-level languages, requires you to enter instructions in the source code of your program. To do this, typically you will use a text editor. An assembler, like a compiler for high-level languages, translates the source code language in the object code. Then, many objects modules can be combined together to form an executable image that will run on the CPU called linking. You can write your assembly language program in any editor and save it with an .asm extension. Then you must leave the editor to assemble and link your program. By assembling it, you create an object file. If there are no errors, you can link the file into an executable file. Now your program is ready to be executed.
Programs consist of instructions and data. Everything in the memory is a number, so careful organization is required to prevent the computer interpreting the data as instruction or vice versa. Memory in the 8086 microprocessor can be segmented in 4 regions. The instructions will reside in the code segment and your data in the data segment. The other 2 segments are called stack and extra. The 8086 microprocessor has a total of 14 registers that the programmer has access to. 4 registers are known as general purpose registers, 4 as pointer and index registers, 4 as segment registers, 1 is known as the instruction pointer, and another one as processor status word. We'll be talking more about registers in the next episode. I should be an actress. I should